Well, gentlemen, I think we get started.
I agree.
Let's go.
All right,
Do
are
it.
we ready?
No, we're never ready, but this is how we do things.
Okay.
Okay, this is what it is. Welcome to BS&BEER Canada. For those of you who don't know me, my name is Aaron Jones. I am a builder and a carpenter on Grand Manan Island in New Brunswick, Canada, and we're doing things a little different today. We are live on location with my host, Ben Station, and we are in the midst, well, I should say Ben is in the midst of a deep energy retrofit, and I am drinking a Baja Light, which I have no idea where it's from, but my guest was kind enough to offer me a cold beverage, and it's quite nice. Over to you, Sean.
Awesome. Hey, everyone. Glad you joined us for another episode of BS&BEER Canada. I'm in Vancouver, a little south of both Ben and Aaron. I couldn't make the trek up there, too much going on and with the activities that I'm up to. But I'm glad to see retrofits because, yes, retrofits are coming. We've got a couple ongoing as well. And I've been seeing tidbits of these amazing details that Ben's been showcasing. And Ben is a rock star, superstar, and has such a wealth of knowledge. And I always enjoy his insights and what he's up to. So I'm glad we're seeing a grander scale of things on his retrofit because I just get these little snippets, just like over the corner there, Aaron. So I'm glad that we're going to see what's going on. And this evening, I'm going local, and the the little kid in me likes apple juice, so I've gone with the bumper crop BC craft cider, a crisp apple, and I'm gonna enjoy being a kid. Over to you, Justin.
Hey, I'm Justin Ott, owner at Element Construction here in Saskatchewan. We do new homes and renovations, so I'm excited to see about this retrofit because I've been really wanting to dive into some deep energy retrofits here in Saskatchewan. So I can't wait to see what's in store. And yeah, I'm kind of actually following Sean. I'm also drinking an apple cider. So cheers.
Cheers, buddy. Gotta love it when it's unplanned, and it is what it is. So hey, we showed up, and here we go.
There we go.
All right, Aaron, let's meet this Mr. Ben Station. Ben, give us the goods, who you are, what you've been up to. I love how in the past couple of years you have just been gathering so much education and training on your email. All of the accreditations is getting a bit crazy with all the little fine prints. So that being said, my friend, you're now taking your knowledge and putting into practice on your house. And again, you're walking the talk, which is awesome.
All right, thanks, Sean. Well, I'm Ben Station. I'm an energy advisor in Kelowna BC here. And what you're seeing in front of you is what I refer to as my sheet show. This is a 1973 modular construction house, crawl space foundation that was a real problem when we bought it. We were from around Edmonton out to Kelowna here, and the housing prices were really, really crazy. So we bought what we could afford in this neighborhood, and what that was a building that was sinking into the ground over here. So we've got a big grand vision for what this house is actually going to be in the end, but what we had to do was make it actually livable first. So we've done the inside over the course of the last year, and now we're really focusing on the energy aspects of it. I've left a lot of things undone. I'm going to stay for BS&BEER, but realistically, it was just a good excuse to be a little bit. So we'll go through a little bit of the details of the things that I'm doing. I am a carpenter by trade, and that's where I started with all of this. And then I moved into becoming a passive house consultant and an HVAC and building control specialist, as well as a.
Can we get your mic volume up?
Oh, sure, yeah. I think Gina muted me.
Oh,
Gina, mute him and unmute me.
We good there?
that's better.
Right on. Okay. So we'll go through some of the details on this place. Basically, what we have here is a 24 by 48 rectangle. It's 1,100 square feet, 3 bedrooms, 2 bathrooms. We were really, really fighting on the space considerations. That's the biggest thing that we've been fighting. this house on. So we redid the inside and we fought for space everywhere we could, but what we're here to talk about is the building science and the energy efficiency of it right now. So you can see that I am plastered out in that beautiful Siga blue right now, and all of our windows and doors are built out in 2x12 bucks. Now, everything's at slightly different stages so that we can see it at different points. This right here, I promise, is not our permanent front porch. This was a bunch of lumber that a buddy gave to me, and we just needed a temporary step to get over the pit that's underneath that. The ultimate vision for the house, and maybe I'll get Gina to pull this up at some point later on, but we are cutting off these eaves. We're elevating the whole roof line. We're putting a 22-foot porch on the front here that's going to come right out to the septic field and give this some curb appeal, because right now all you see from the exterior is this wall, and it is I mean, it looks better in Siga blue than it did before, but it used to be just absolutely hideous, and there's no curb appeal for this place at all. So we're adding some depth and dimension. We're adding a bunch of exterior insulation. We're installing a fully wrapped, what's called a gift box wrapped air barrier. So all the siding came off, and then when we do the roof, we're going to cut off those eaves and wrap right over top of the existing structure before we put the new roof on and build the eaves out and everything here. So this is actually going to be the plane of the insulation put on here. We're certifying this house as the first EnerFit in the Okanagan if I do everything right and I pass everything. But what that means is that we're adding about 11 inches of dense packed cellulose to the outside of this. And the reason we're cutting off the eaves and adding the extra roof is actually because we have only about 3.5 inches of insulation room at the eave there and no room for venting. So we just have nowhere to go with this in terms of energy efficiency. Got to cut it off, give us some space to do 2 foot of cellulose up there. We started at I think 7. Actually, there's a guy on the call here who could probably answer this for us, Brett from who's another energy advisor locally here, but I think we started at 7.9 air changes per hour on this house. The last time I tested it, we were down below 3, and I hadn't done the fen trim tape around the outside, and I hadn't taped in the windows on the inside. So what you're actually seeing here, this is our air barrier. It's actually a WRB as well. This is the self-adhered Siga MyVest 500. It's been great for me in terms of staging this out and moving through and doing things little section by little section, because if you've ever done and lived through a renovation, you know that fighting for places to live your life normally within the building is really, really difficult. So I've been doing things in little stages, and this is the plan I came up with to get that done. But this is actually not our primary WRB. It's functioning that way right now. It wraps in, and we'll take a look on the inside. It wraps into the inside of the jams, and then is actually just our air barrier. So we're connecting from the backside of all these windows back to the air barrier here. And then we'll be putting on Larson trusses on the outside here, a new Siga 200 loose lay membrane, and dense packing cellulose in behind that. So that's how we're getting up to our really, really low U values that we need in order to meet EnerFit. And this whole side of the house, and Aaron, you can kind of show them down here. See this giant crack in the foundation down here? This whole side of the house, from about 24 feet, starting from there, had sunk about 7 inches because people did not manage water well. Now you can see I've got a really ugly eaves trough here right now because I need to keep water away from the foundation. But the first thing that we had to do with this place was dig up all around it. And I had a really good company in Kelowna here, Techno Metal Post, drive a bunch of piles around the outside of the foundation, bolt onto the foundation, and lift the whole foundation. It was 7 inches at that corner that we had to come up to become level and get to just a place where we could start working on the house again, right? But we didn't have the budget to tear the place down and start building again. We only had the budget to salvage what was here. And from an environmental perspective, I'm really glad that we did that as well. So that's kind of the big story of the house. I've got a mock-up in the back, a full-size mock-up that'll show you exactly what we're doing with the elevated roof detail and everything like that. I'm sure it's probably only been 5 or 10 minutes. It feels like I've been talking for the entire hour already. So I want to see, first of all, if Aaron or Sean, if you guys have any questions about what I've just said before we move into anything else here.
You have to understand, everybody that's here loves a good mock-up. We want to see your mock-up. We really do.
Okay, let's go in the back to the mock-up here.
100%. And I mean, right now, Ben, nice clean lines. Your work is meticulous, and love the detail, the thought process, and just again the story of what you've been up to. So this is great. So keep it going.
Well, thank you. So I
And
guess
after we see the mock-up, I've got questions for Ben on some of these flashing details. So, I mean, if you know, you know.
You know.
Okay, well, while we're doing that, I don't know if we can send the dog for more beers or what we do here, but happy to talk about the mock-up without the beer. So here we have, and this will be, anybody who's lived through a renovation knows how embarrassing it is to have people see your yard and your home while it's under renovation, but that's just the reality of it, right? This is the mock-up that we built. If you maybe want to go over there, and that's probably a better angle for it. So what we have, we'll get to this. These are my doors here. But I've built this, and it's been annoying my girlfriend and my neighbors for many, many months. But it's really important to understand what you're doing and why you're doing it, right? So I built a full-size mock-up so I could see all the details. And here's what we're doing. This is the existing wall of the house. This is the existing roof of the house. And that's how much room we have for insulation. The shingles are right here. Ceiling finish is right here, right? So in order to reach anywhere close to the insulation values that we need, even to be a reasonably efficient house, we had to add some space to the roof here. The solution is, because we're adding so much exterior insulation, the overhangs were only going to be to here already. Well, why don't we cut those off, lift the whole roof, build a pony wall here, add a new roof with a 3-foot overhang, which actually becomes a 2-foot overhang once you build out to the point where the bucks are. And this just helped me really figure out some things. I have, oh, that's got to be Gina. Thank you. So I built this, and I went through some flashing details and playing with some things, and it just wasn't quite working. So I actually ended up reaching out to both Sean and Aaron here because I had some questions about how I wanted to do things. I'm so used to installing nail flange windows, and I know that in the high performance world, not a lot of people do high performance builds with nail flange windows, but that's what I had the budget for. And we ordered our windows before we left Alberta because they were 60% cheaper to get triple pane in Alberta than it was here in Kelowna. But I had some questions, and I had some things that I didn't really know how I wanted to do them. Ultimately, we're in a very dry climate here, so it doesn't really matter. I've left things exposed for months here, and it never sees water. But I wanted this project to kind of be an experiment and to go through some things and learn some things for myself as well, because it's fine to draw details and to know things, but to actually have to go through and build it after is a completely different process. I had thought that I was going to tape in my bottoms of my windows because I was going to seal them up completely and trust my overhangs, everything like that. And I sent this picture of this mock-up to Aaron once I was finished building it. And he said, I wouldn't tape in the bottom of your window. You got to leave something for free draining. Even if you've got free draining ports in your window here, you want to allow it to free drain a little bit better than that, right? And I went, you're full of shit. And then I thought about it more, and I did more looking and investigating and detailing. And I went, yeah, you know what? I need to make a path down, out, and away for all the water that could potentially get in there. And so I changed the detail. I built a full-size mock-up, and then I threw it out. A lot of it anyway, because I wanted to make that pathway. So if we come over here, I'll show you. And then I want Aaron to really tell me how I screwed this up or where I have shortcomings here. So this is where we ended up. This is a continuous aluminum and bitumen sill that goes up and is sloped up behind, and then on top of XPS and up behind the back of the window. So if anything ever gets inside this frame, and we do have weep holes here, but if anything ever gets inside this frame at the back, moisture moves in, anything like that, it has a path down, out, and away, free and clear. You can see there's actually like a bit of a space behind here, so that this is what we would call a partially or semi-ventilated cavity. So this is continuous, comes right up on the sides and all the way behind. I can't find a fault in it. I don't know how moisture could ever mess up my bucks, but Aaron, what did I mess up?
Hey, Aaron, I think there's that whole thing about belts and suspenders, and then there's belts and suspenders plus belts and suspenders. And like, you're right, this thing is skookum. I've seen it in your Instagram posts and you talk about the layers. I mean, most people say belts and suspenders when you put a back dam in. But the fact that you've got it raised up and a back dam and, 3 layers there of the sill product, it is as bomberous and get, man, like that is it's beautiful and it's interesting. So I would agree with you that in North America we don't trust windows. We've never trusted windows. We know that they've been the leaky sieves of our envelopes, but I mean most Europeans, because their windows are so good, and they do tape the outside, but I mean we have some friends in the building science world that say, the thing, water will get in, and if it does get in, will it get out? And so we should just always lie in that precaution of, if most industrial manufacturing is like 95% perfect, you know what, and there's a 5% error, you might as well just allow for things to do what it needs to do. And so you allow water to get out if it gets in. It's amazing.
To briefly quote Dr. Joe, there's 2 types of windows: windows that leak and windows that are going to leak.
Yeah. So I mean, I really do like that I've got a path thing for the Sika tape. Great place to use it. I did some sort of wing nut testing on this to make sure there was compatibility. But to have that split backing so that I can tie this into my permanent WRB at the end is just awesome. I love this. I do love this detail. It's definitely overkill for the dry climate that we're in Kelowna here, especially that we're going to have 2 foot overhangs here. But if I'm going to tell people to build something, I may as well have built it myself. And that's why I got into this world, because
You have to unmute,
You're on mute.
you muted me.
but I can't unmute you. Sorry.
All right.
If you want-
There you go.
you can use yours.
Okay, so then he has to mute now.
Vice versa.
Are we getting some
Okay,
echo?
Are we good?
I think we're good.
I think we're good now.
Right on. Yeah. So to give you the contrast, actually, because you're making the comparison between European style window frames and what we've got here. So this is traditional North American windows. These are metal exterior, black, and vinyl for the rest of the construction, right? And they're what you would see on most builds throughout Canada. And they're good windows. They're good triple pane glazed units and stuff like that. I'm happy with the performance of them, but I've done the thermal modeling of them. They're going to be losing a lot. Like there's no thermally broken frame in these. Then if you come over here, I'm just going to move this. There's probably going to be spiders under here. Nobody should worry about that. But what we have here is this is the old step from the old door. So this is from Inotech. And this is not, I called it the 88 pH. This is not the Passive House certified. They can't get the certification on the lift and slide here. But this is a completely thermally broken, really, really nice lift and slide door here. And the performance on it is pretty incredible. Like when you see how this thing moves, but also just the thickness of it, the beefiness of it, the extra seals that exist here. How this works is it has a carriage underneath it that picks it up so it can move freely. And actually, here, Aaron, step back a little bit, because I've never had a patio door that does that before.
Yeah,
The
it's
soft
gorgeous.
close. I just love that. It just makes me happy every single time I use it, But there are some certain considerations you have to take in order to install something like this really well, especially because we're building it so far out in a 2x12 buck, right? This door is, to be technical about it, it's pretty fucking heavy. And I had to dogleg back into the floor system here. So we've got actually extended the floor support coming out. And then in order to thermally break it, it's actually sitting on XPS. But the door is so heavy that you worry about it crushing the foam that's in there. So actually, I'll grab that later. We'll go through how I've installed these doors in order to give them proper support, but also thermally break the frames. Because the biggest thing that I wanted to avoid is any possibility of any condensation on any of the interior surfaces of my windows and doors. That's the number one thing we're trying to avoid. And in order to get this certified through Passive House International, I have to model every single thermal bridge, right? So this is a difference between those window frames that are traditionally manufactured here and this. I'll just grab the mock-up. I'll bring it over. Actually, Aaron, maybe come over here. I've got the other one. Oh, I'm getting too excited about details, so I'm leaving my beer around. So I kept the actual existing door because I thought it had some really good learning opportunities on it. This is the door that I pulled out of here, and now we got that nice Innotek door in there. There's a reason that we don't want to rely on spray foam for air sealing around a door. And you can see it here very, very clearly. This is the shim point, right? These are the shim locations. And you want to tell me that you're not getting air leakage in between there? Like, this foam was not adhered. You can see that you're going to have air leakage at those points. It's not consistent. We can't tell the quality of the install. And the insulation doesn't go the full depth of the jamb. So that's not really a big problem when the insulation isn't behind the jamb at this point. But once you get back to here, where you're in line with the plane of the door and you've got air as well as just shims and a thermal bridge there and air leakage, I think that this is a really great way of illustrating why we don't want spray foam as our primary air barrier on a door installation. Why we want to go to something like a tape or something like a backer rod and caulking, you know, like. So I just wanted to keep that. I'm so excited to get rid of this door and not look at it anymore. But I just kept it around because I wanted to show that, because I think if you know about the ways that air can carry moisture and the way that that moisture can then negatively affect your building envelope, this is a great place to just see it. Like, oh, absolutely. And when I pulled this door out, the opening that it was in, we had black spots around here because you could tell that it had been getting wet because things weren't sealed up properly. And in the wintertime, that warm, moist air is traveling through, condensing within there, getting wet, causing mold, causing problems with indoor air quality, all of that stuff. So that's what I wanted to touch on with that. Now, we go to the doors that we actually have in here. And these are the cross sections from what we chose to put in. Now, Innotek is a premium brand. They are expensive. This is something I chose to splurge on. But you can see the absolute difference here. This is the door section itself for the 88 Passive House certified door frame. This is the frame. This is the swinging section here. You can see these chunks of foams and the effort they've gone to thermally break these assemblies, as well as the way the glass assembly is put in with multiple seals and thermally broken, right? This is what we've got in on the house now. And when you take a look at that, and then you compare it to this as a cross section, right? You have a board. And then you have a door that swings closed against one seal that's never done well and always leaks, especially in the corners. And you've got that one seal to rely on. That's the only thing you've got to rely on. This is why doors frost up. This is why your doors and windows are the weak link in your building envelope. Yes, your walls are always going to have a better R value than the actual door assemblies. But when that's all you're relying on is just one little weather stripping, and it's outside air here, and a 1/4 inch away is inside air, that's just not where we need to be for thermal performance. You're going to be wasting money on energy. You're going to be wasting money on a lot of stuff for the life of it. And I agree, and I understand that this is a much more expensive product. But look at it. So there's a lot of companies that make really, really good versions of it.
I'm going to interrupt you for a second. I just want to say a friend of many of us likes to remind us that good things cost money. And I've had the good fortune to install one Innotech window all the way out on the East Coast, and it was worth every penny. So if you're looking for performance, this is a solid option.
Absolutely. No, I agree. And this is the swing doors. That's how we have them. This would actually be the inside face. You can see we've got 3 seals. This might be a threshold. No, there's a seal there, a seal here, and a seal here, creating 2 closed chambers functioning exactly like a triple pane window, right? Rather than having this one seal that the door closes against, and then your inside area is right there. That's the real problem.
And thermally broken.
And thermally broken, right? You look at this still down here. This is a chunk of aluminum that runs all the way from outside to inside. Well, no wonder you get frost on those at the bottom at the end of it. So the other part, just to stay on the door just for another quick second, we've had a lot of wind here. The dog's dish is really dirty. If you come right down here, Aaron, and just take a look at so this is actually XPS down here, and I've left this. It needs to receive into something else. I want to explain too much. Don't worry about that. So we've got a completely thermally broken frame install here with little weep holes that are cut into the XPS here as well. But this door is about 900 pounds. So the way that I solved for that, and this is a detail I hope some people will try out, and I want to hear if you're critical on it. I'm just going to go grab something. I'll be 1 second.
Aaron, when he comes back, let's just like from a structural standpoint, did I understand it? It's wood, foam, wood, or is it just foam and then wood, and then the?
I think he's about to explain it.
Oh, okay,
So
here we go.
We'll give him a shot, and then we'll break it down.
So this is how I've done it. I decided that with this foam, because we have a 20 PSI crush strength on it, I decided that I wanted the bottoms of the doors to crush into the foam a little bit. So I gave them about a 32nd of an inch crush, because the foam ratings, when you see a CFM, it's going to tell you the amount, the CFM. When you see a PSI, it's going to tell you the amount that it can crush down to 10%. So if you have a 20 PSI rating on a foam, that means it's at 20 pounds per square inch, it's not going to crush more than 10%. So I figure that I want the door to crush into the foam a little bit to get solid bearing all the way across the frame, but I core out and put wooden blocks in each of these, which don't interfere with the actual thermal break that transfers all the way inside. And I made these sills for everywhere around there. They sit on top of the aluminum portion, and they have drainage channels out the back. This goes around and up the backside, and then is taped to the backside of the door and transfers to the air barrier. So I think it's pretty good detail. It breaks everything thermally. It allows me to push this door out into this buck and still separate it. What did I miss? What did I screw up? Oh, it's just different foam. This is the DuPont crap. I actually use Sopra XPS on this because it has a global warming potential of 1, rather than this stuff, which has a global warming potential of you don't want to know because it's terrible. XPS is all terrible except Sopra, and I will say that with confidence. Sorry, I have a lot of thoughts on rigid foams. Like, why would you, if you use a blowing gas to make this, why would you want that blowing gas to be 750 times as potent for greenhouse gas effects than carbon dioxide, when you can get one that is equal to carbon dioxide? Why wouldn't you use that? Anyway, so what was the question?
Nailed it, except for the structural.
So the structural part, what I've done is I've dog-legged back in through the floor system. So we've got, number one, we've got the 2x12 buck supporting it on the outside. That's bolted back into the vertical supports of the frame. And then along the way here, we actually have 2x6s that are dog-legged through the floor system going back to joist bays. The actual point of support is the backside of this door. So the backside of this door is actually only about 4.5 inches outside of the plane of the foundation. But in order to make sure that that's bomb-proof, I dogleg those back a couple of joist spaces. And I did the very technical jump test on each one as I put them through. I set up my camera, took a video of myself jumping on it, and then I zoomed in to see if there was any deflection. I didn't feel like getting engineering on this. I know that this door weighs 800, 900 pounds, whatever it is. If me as a 200-pound person can jump up and down on it, it's good on each individual one. Basically, perpendicular here. Correct. Tied in through the spot. Yeah, and and the whole purpose for that is because I wanted this to be like, we're going to have an elevated patio surface here on tile pedestals, but the flooring I wanted to come in and just be less than 1/4 inch below this surface. So this flooring was installed temporarily because we weren't going to be putting that in, but the flooring will come up and then it comes straight out to here. So I wanted the door sunk below the floor surface, just because of the effect of having that floor float straight into here, and then our tile surface of our deck is going to be right here. So it's going to be pretty barrier. Hi, buddy, you're being real needy. Yeah, so that's why I did it that way rather than bringing it out with full width joist.
Ben, I love how you just have a very passionate student that is just wanting to learn and wanting to get into the details as much as you do.
Yeah, I don't even notice them sometimes, but yeah. So that was one of the big details that I really like on this. And I like that I'm figuring out how to stage things in process so that we can do things as they go along. You know, I don't necessarily always work in the best particular order. So being able to have receivers and have things fold in and go as they're ready and go on to the next process is really important for me. And that was great with the self-adhered. Any of the self-adhered WRBs that are an air barrier are going to be really, really great for that, especially in a renovation project. And then they give you that added protection, right? Like if you see up here, this door is like that can get rain pounding on it, no problem. Like it's all tied in and it's sloped away and everything. I think I've covered everything about windows and doors on here. What else about this project? I've been yapping for a long time.
Oh no, it's all good, buddy. There were a couple of comments. Mr. Bob Kelly talked about a thermal bridge with that aluminum sill tape, but I think he might have been using a different product.
No, that's actually a valid question I've asked myself as well. This aluminum sill tape is super, super thin, and it's on top of the bitumen backing. I have a concern about that, maybe, but ultimately what we're looking for here is durability as the absolute number one thing, right? So having that, it's better than having a sill pan in there, which is going to be a thicker gauge metal, right? This is a nice thin little piece of aluminum that can't really carry that much energy because it's so thin and on that bitumen. And I would rather have that and know that it's bomb proof from a durability standpoint, and maybe have a little bit of a performance loss, because I could have used the Sega products to do that. I could use the Wig Glove and make a sill up that way, but I wanted to have a little bit more beef there and be able to feel confident in it. So very good question. I went through that myself.
And the other one that came from Mr. PH Molnaire is the international space underneath. Sorry, is the intentional space. Sorry, I thought he thought we were off in the moon looking at in outer space stuff. Is the intentional space under the window filled with intangible mesh product to prevent intrusion by most insects?
No, he's talking about underneath here, sort of that interstitial space in between the window jamb and here.
Yeah.
Yeah. So no, it's not, but this is getting over insulated and capped. So this is going to get a broken capping that goes all the way around the window that is set up in the same shingling flashing setups. This is going to have mineral wool on here, blocking it in the front. I didn't bother. This is about a 16th to an 1/8 of an inch in behind here. I didn't bother blocking that with anything. I just want that to be able to free drop if there's ever any water in there. But it'll be covered in the front with mineral wool, and then the capping will be completely on there and sealed. So I think that I'm worried about bugs too. That's a big reason for the fence trim down here. When we cleared out that crawl space when we bought the place, we spent my girlfriend she was down there for almost a week with me cleaning out that crawl space, and a lot of that was vacuuming up spider webs and dead spiders and all that. So we want to avoid that, and we all know that bugs follow air leakage, right? So
yeah, they like the warm stuff. So just talking about your crawl space, then what will be the air barrier? Is it the OSB subfloor sheeting that you've got down right now, or are you going to put down another membrane on the bottom side of the crawl space to help create some air tightness on the bottom down there?
yeah, so what we have in the crawl space on the dirt floor, I built up 6 inches of foam insulation, and the top layer of the foam insulation was all taped together. So that kind of helps, but mostly that was just to hold it together. I wasn't being particularly fastidious about that. Above that, we did a full 6 mil poly roll. We didn't go as far as the green stuff, but we did a full 6 mil poly completely taped and sealed as a radon barrier. And then on top of that, we've got a staggered system of 2 layers of OSB that are lapped and staggered and laminated together with screws. And then we're using the Seeger Reson tape on all the joints down there. And then that ties in. So basically, this air barrier here comes down, transitions across the mud sill right there. The mud sill takes that in, and then we'll use fence trim on the inside as well to transition that over top of the interior insulation. I haven't insulated the walls of the crawl space yet, and now that it's becoming summer, I'm not going to, because may as well get another little bit of cooling effect out of it for 1 more year until insulating it, right?
Totally. Beautiful.
The thing I'm trying to figure out right now is how I can heat my pool by cooling my house. And I can't find a heat pump product that does that, but that's the next thing I'll have to do, because we're paying to cool the house a little bit right now. We'll be at passive house standards soon, so it won't really be that much energy. But yeah, that's the next thing. I want to heat the pool from the house.
Awesome stuff.
Well, if nobody else has any questions, I'd like to highlight a few cool things going on at the mock-up that Ben didn't take the time to, or maybe he didn't think they were cool like I thought they were cool. So what I've noticed when most people are doing a mock-up is they mock up only the detail that they're looking at. And while, Ben was mostly concerned with his window, he did the wall, he did the roof, he figured out his overhang. And I thought that was just excellent, because I've been guilty of this as well. I'm worried about a window detail. I mock up the window detail. I don't always do a complete wall roof section. And I thought this was excellent, because this also gave him kind of an idea of where your shading was going to be at. How much shade is your overhang? Because you can pretty much move this around by yourself, can't you?
Yeah, your beard's on there, so I won't right now, but yeah, I didn't actually do this for the shading detail.
Where and we lost him. Sorry, guys.
I had muted myself. Is that okay?
Yes.
Yeah, so I had a full shading analysis of the entire house. So this wasn't really because of that. But this was more just because I wanted to, because I know that mock-ups are really important for understanding all this stuff. So yes, that would work really, really well for customer communication and stuff. I had the full shading analysis, but thank you for saying that. It also gives me it allowed me, it was a communication device for the girlfriend because she's the customer basically at this point, right? I'm just out here spending the money and doing the work and doing things, and then once in a while she checks in and goes, "Hey, what's this about? I saw 10 grand come out of our account," or whatever it is, right? So yeah, that this it's a mock-ups are great communication devices, and that's part of something I'm doing with my envelope designs for builders and stuff like that. Is that includes on-site building of an entire mock-up with their trade team, because we want to normalize that type of practice, right? So thank you for noticing that and saying that. I'm so excited to smash this thing apart and get rid of it, though. I am really, really done with this existing in my life.
Good looking mock-up. I mean, you could almost like take it down to Penticton and drop it off at the school there and let them look at it. So careful
Tell them
where
they're free to come pick it up anytime between now and Saturday afternoon.
Got it.
Right on. Anything else that I should be worried about talking about? I know I talked a lot and we're probably running out of time, actually.
Oh no, we're good, buddy. No, we're good. Question for you regarding structural on the window behind you. So you've got like those little L angles below.
Mm-hmm. Yeah.
Was there any other specific details you need to do structurally from your engineers
Yes.
to deal with the load of those windows?
So I'm not super concerned about the load of the windows. The buck itself is carried into the header above, but these are just temporary. We're doing the Larson truss on the outside to accept the insulation. Underneath all of the windows, these are going to get framed in with actual vertical 2x12s all the way down.
Okay.
But in
Okay.
order to handle some of the air sealing details and the other things, I just decided to do this temporarily. And I don't even know if I'll end up taking those out, but I needed something to support that, because like our countertop actually extends all the way out beyond the wall. It extends right to the back edge of this window. So I needed something to just be able to finish it properly and take that structure at this point in time. But with the floor system being right here and a bottom plate of 2x12 and then verticals on 16-inch centers, you know, we'll take the thermal bridging hit of a 2x12, which is really almost nothing, to get that in as
Nice. Beautiful.
full support. Yep.
There was one question, and not sure if I want this recorded or not, but Pete says, was there any pushback from local municipality for the increase in building size? And or is your feel that the authorities are coming along? He's loving the walkthrough.
Let's stop the recording.
Yeah, I got it. Okay. So
no,
moving along,
no. It's fine. I'm completely fine to talk about this. So we are, we've got certain permits on this project. We are waiting for permits right now on the front because we're going into the setback expansions and stuff like that. We have a large amount of expansion into the outsides, and when we're just replacing windows and doors, I probably should have got the building permits for it right away. I know that I might take some heat for that, but I didn't, because I was fighting with engineers for months about how they wanted the roof to be done. And mostly because they wanted penetrations to the air barrier on 16-inch centers all the way along the outside, all the way along the ridge, all the way along the outside on the other side. And so it was a bit of a problem there. In general, we didn't change a whole lot for the layout inside the house, so I didn't feel the need to go for permits on that. It's mostly aesthetic things. The exterior here, we will have the permits in hand right away. Luckily, we have the city of Kelowna here, which you guys are going to hate this. The city of Kelowna is the greatest city in the world, not just because of how it is to live here, but the planning department is the most helpful planning department I've ever had to deal with. They are so supportive. They're wonderful in every way. And I've gone to them with questions about this, that, and the other thing. And every single time it is, let's figure it out. Let's put you to who needs to hear about this in order to help you most effectively. That's the way that the city of Kelowna works. And so I just can't say enough about them. I've been in touch with them about this project a lot, but no, I didn't pull building permits for doing the windows and doors. That'll go on as a wink, wink, nudge, nudge with the roof extension and the expansion and all that.
Yeah, fair enough. I mean,
Taking
yeah,
credit for
this definitely Penticton, city of Kelowna, are on board with the step code, and so that's fantastic that you feel supported. We have some municipalities here in the Lower Mainland that are even not on board as much as Vancouver and Richmond and in the North Shore. So glad that you've got that support. That's great.
Yeah, and I mean it's the whole ask for forgiveness, not permission. I don't generally ascribe to that, but I wouldn't, on a project in Alberta, I wouldn't pull a permit for replacing windows, right? So the fact that I've replaced windows and I've built them out a little bit for adding exterior insulation in order to meet advancing energy codes, even I feel like I'm safe and clear. Or maybe I'll get slapped down for this. I don't know.
Again, you look at the details of going from 7.9 to 3, and you're probably even better now. I mean, again, some of these things are a bit of a model for other opportunities and other clients. I mean, I actually didn't know that it was modular, and the fact that it's that aspect as well as retrofitting, because one of the passive accelerator features we did was this affordable home where they bought a modular thing just like yours right out of the factory and literally did a retrofit the day the modular arrived because they knew they couldn't get the local trades to do things in the factory. And so they
Right.
just bought it with the Tyvek on, and then they just did Larson trusses like you did. And it worked out to be a bomber home, and seeing the details you're doing here, it's just amazing. So yeah.
Well, and the big thing for us was budget, right? Like what we paid for this house was essentially lot value. We're rescuing it. It probably should have been torn down, but we chose to fix the foundation, do all the work to do this from top to bottom. But I mean, people always ask me about budgets and stuff like that. Like we're into this. By the time we're done, we're going to be around 140,000 because I'm doing all the work myself, right?
Yeah.
When you look at a retrofit this extensive, generally it costs a lot more. But the big thing that I've been trying to do is try and bring in practices that advance the energy efficiency and get the building brought along with a low budget. And like the girlfriend does not feel this way, but I have been merciless with the budget. There are so many things that I've done that have taken me 2 or 3 days to do because it saved $200,
Yeah.
So that's dumb. I shouldn't do that, but that's what we've been doing. And we're gonna end up with it doesn't look like it now. I'm glad that the people on this call can appreciate this and see this and hopefully see the end vision. I feel a little bit insecure about how it looks right now, but I know what it's going to be like in the end, and I'm pretty happy with it. And we're thrilled to live in Kelowna, right? Like moving from Edmonton, it's just the prices are a little different. So
Well, I think you will agree. Yeah, the people on this call like the Siga blue, matches the sky, and the Intertech windows look bomber, and all the details are just skookum. So I mean, honestly, I'm like, forget it, leave it as is, and let's test out the UV rating of that MyVest, and let's go from there. So looks great.
it says 6 months. I've got a couple left.
Yeah, don't worry. I've pushed the Mento a few months on a different few things, so I hear you when you're doing your doing your own projects. But I mean, the best part too of this is right. It's your home, it's your story, and the details you have, you get to take away. Sorry, question came up from Ashley. Hey, do you have any renderings of the final product that you can share? Is it? I mean, I know we're 50 minutes into it, but should we dive into
and
the
sorry,
computer
because we
stuff?
got to talk next events and stuff, and we got to get out to the local. But that's what you get when you get Ben talking about building sciences. You get a lot of talking. I do actually have renderings of the final. I don't know if Gina is I sent them to the Outlook email. I don't know if she's able to pull those up or anything, but it's not that much different. it does just have an intersecting roof, higher roof lines, steeper roof lines, that kind of thing. We're not changing it that much. Because we didn't want to do we didn't have the budget to do an expansion, right? We're 1,100 square feet and it's 2 people, and that should be good enough if you design it well. But yeah, I mean, we can go back inside, but we get
Yeah,
problems.
fair enough.
Audio.
Or you can run and grab it, and I can entertain folks for the next 5 minutes while you run and grab it.
Yeah, just don't show them that direction.
Yeah, fair enough.
Okay.
Well, Aron, why don't you talk about what's happening next there in Kelowna? Because this has gone from a virtual event to then a time where you're actually going to meet people in Kelowna and hang out and talk about more fun stuff. So talk about Copper Brewing. Oh, you're muted. Sorry. Hold, Aron, 1 second. You're muted.
Yep.
There you go.
Sorry.
No, all good.
First of all,
You're sure?
I appreciate everybody working through the technical difficulties with us. This is the first time we've done a show in this fashion, and there may or may not have been a small learning curve behind the scenes before we got started, but we're making it work. But anyways, long story short, in about an hour and 8 minutes, we will be at Copper Brewing. We have a little private room set off next door. I don't know exactly all the details, but we're going to be at Copper Brewing. We're going to be doing a building science and beer meetup in person in Kelowna. We have an RSVP, but we're competing with a beautiful summer day, basically here in Kelowna, even though it's spring in much of Canada, on the Thursday of a long weekend and a hockey game. So there's people that are going to show up. And if you're on the fence because you think nobody's going to show up and you're thinking about watching the hockey game, I have it on good authority that they have a TV there. And we can do building science and hockey.
Gotcha.
So
yeah, so
6
when
o'clock, local time, Kelowna, Copper Brewing.
So when Ben comes back, let's see how quickly the local community either is in favor of his hockey decisions and his team that he favors, or if I will turn him off and not like him anymore. So we'll see if he's an Oilers fan or a Canucks fan. I hope he just stays in Kelowna and takes the middle road, and which will be the high road.
Well, that could be. I know if he goes too far, Gina will just end the Zoom.
Yeah, that's it. Hey, Mr. Bob Kelly, your Connor Bernard is doing amazing for Canada in the World Junior. So good Canadian kid down there in Chicago. I love it. Ben known Bouchard fan, maybe so. Good stuff. Hey, again, thanks, Aron, for the travels. I know that you're there for family and other things, but setting this up has just been awesome to see. For those that haven't been connected with Ben to date, you really need to connect him. He is a brilliant guy, and if you look at his Instagram feed, man, he has built some beautiful things in his career. There you go. Oh. All right. So I will say, Ben, I did live in Edmonton from 1982 to 1985, and my jersey,
Good years.
my wife and kids can wear my jersey. That is a lot more dated than that one you're wearing. So I'll let you get away with it today.
Right on.
Oh, here we go.
Here you go, mock-up time.
Oh yeah, so this is, I mean, like I said, it's not that much. We're doing a 22-foot porch across the front and peaking up lifting the roof 2 feet at the front and changing the pitch a little higher. And that's about it, like it gives it, that's what it looked like. That's what it looks like right now, right? So it's just a bit of a curb appeal change. And actually, Gina, if you, for one more little thing, if you go to like page 8 or 9 or something like that, you can see I drew a lot of stuff on. Oh, right there. Yeah. Yeah. See, if you zoom right in on that, that is the cross section of what was existing and what's new. You can see the existing trusses and then how the new roof line is going to be just a little bit more of a pitch. And then the elliptical Larson trusses I've designed for the outside.
Love it.
I love
Yep.
this too, because it's
Yeah.
a clear demonstration of, like my friend Ben Bogey likes to say, high performance can be simple, and it should be. So, this is simple. It's clean lines. Although Ben has put a substantial amount of work into this, it's not overly complicated, and it's going to perform amazing. I'm actually hoping that Ben will allow me back when he's got his exterior insulation on, and maybe we'll do a blower door together.
Always got the blower ready to go.
All right, I think that's it. My next Kelowna trip, blower door time.
Maybe I could meet you there with something that will help out. We'll see.
Scotch.
Ooh, I like it.
Both
like
that
it.
too. Sorry, Aaron, you can't see it. I'm holding on my retro tech kit. So, but Ben, I like where you're going there. I like your attitude. That's perfect.
Well, I have been known to travel with a blower door.
Yes, you
So,
do. So Ashley wants to know elliptical Larson truss. Ooh, where did that crazy idea come from?
That's a talk for another time. It's a whole idea and a whole product thing I'll be doing later on. But
okay,
Love it.
so
Stay
there we
tuned.
have it. We're officially inviting Ben back on the show again when he does the elliptical Larson trusses. We're booking you in right now.
Yeah, I really think
I
this
made
is a
up that
part one
name.
of potentially three.
I just made up that name as I was going. I said elliptical Larson truss. I've never said that or called it that before. So sorry, Ashley, but I'm calling it retro stud.
Retro
All
stud.
right.
Oh, I like it. I like it a lot.
I would even argue there may be two studs standing next to a retrofit.
Both right here.
Awesome, you guys. Well, again, if there's any more questions, chime in now. Otherwise, we should let these guys wrap things up at Ben's amazing house and retrofit, and they can head on to the next part of their evening.
Cheers, everybody. Thanks for tuning in. Thanks, Aaron, for coming down for this. And thanks to everybody for listening to me yammer. I've lost my voice already.
All good stuff. And
I
again,
would like to thank. Go ahead, Sean. Go ahead.
No, I apologize to the community here for answering the questions. I knew that we were kind of limited on time, and I want to make sure that everyone at least got their questions asked and heard. So normally we do turn it over so there's more interaction, but we do appreciate the attendance. They appreciate all the great questions, and you two studs looking good.
Let's go.
And we're done.
Anyways, yeah, I just want to say thank you to Ben for showing us not only an amazing project, but your own personal project. And I would like to highlight that he is doing some pretty high quality and very efficient stuff on a budget. And that's important to know. And I think in the next decade, we're going to see a lot of retrofits happen. And projects like this are key for learning. And we should take every little nugget we can find and apply them wherever we live.
And look for your local BS&BEER chapter. We've got one in the Okanagan here that's awesome. There's probably one that exists around you. I hear that there's one getting started up in Vancouver. Sean, maybe you can tell people about that. Get some eyes on that.
Yeah, no, Thomas is working on stuff. We're definitely planning a bigger event next year, and we'll try to figure out some more local stuff very soon. In Vancouver, Haven had a really big builder expo last night. That was a lot of fun, and hopefully we can maybe have some little more mini size events in the months to come as we again connect, build a community, and get more of these conversations happening. So that's the best part of it all.
Right on.
As always, to everybody out there watching and listening, if you have a question, never be afraid to reach out. Just about everybody in the building science community is happy to answer your question. And if they don't know the answer, they usually know somebody who does. And we can point you to Ben, to Sean, to whoever it may be. There's always somebody willing to help. Anyways, thank you very much, everybody. This has been amazing. Thank you again, Ben. And we are going to Copper Brewing and doing a little local BS, if you will.
Bye, everybody.
Good night.